Hello friends, let us start a new topic today, which is congenital heart diseases. Congenital heart diseases. So before we deal with the congenital heart disease, first let us learn about the development of the heart, which is cardiac development. If you see, this cardiac development occurs with the help of some regulatory proteins. These are transcriptionally controlled. These are controlled by transcription. And these regulatory proteins will activate or inhibit certain genes, targets in specific time and location, at specific time and location, resulting in a finely tuned process, which is called as cardiogenesis. Cardio is development, cardio is heart, and genesis is development or production. So development of heart, that is cardiogenesis. Basically, at 3 weeks of intrauterine life, there are two major areas which are called as heart fields. There are two heart fields. They are cardiac crescent or first heart field or pharyngeal mesoderm, which is the second heart field. Both cardiac crescent and pharyngeal mesoderm develop a cord, which is called two cords separately, which are called as cardiac cords. These cardiac cords undergo canalization to form two cardiac tubes. Canalization is formation of lumen in between the cord. So that is formation of two cardiac tubes. Right? So now these two cardiac tubes, which are formed from pharyngeal mesoderm and the cardiac crescent, these two cardiac tubes will fuse to form one cardiac tube. They fuse to form one cardiac tube. This occurs by 21 days. So now this cardiac tube elongates, and then this forms constrictions from caudal to cranial end. So these are the it elongates and forms constrictions. So let me name these constrictions in the next page, right? I'm sorry. Yeah, it forms constrictions. 1, 2, 3, 4, 5, 6, 7 constrictions. The heart tube forms, the cardiac tube forms 7 constrictions, and they are named as follows from caudal to cranial end. Caudally, they are called sinus venosus. This receives blood from the vitelline vein, umbilical vein, and common cardinal vein. And the second one from the caudally is atrium, then ventricle, then bulbus cordis, then truncus arteriosus, and then aortic sac, and finally aortic arches. So these are the things which are seen from caudally to cranially, right? So this has 3 openings, 1, 2, 3, Vitelline veins, umbilical veins, and then this one. Now what really happens is, at the bulboventricular portion, this moves rightwards, rightwards. This bulboventricular portion will move rightward, and this atrium and sinus venosus goes posteriorly. So if you see, I just need a paper. Yeah, just a minute. Can you see this? It's quite bigger, right? Okay. Think that this is the stuff, and this has 7, 1, 2, 3, 4, 5, 6. 4, 5, 6, 7, right? 7 things. So this is arch, aortic, so come from below downwards, sinus venosus, atrium, ventricles, bulbus cordus, truncus arteriosus, aortic sac, and aortic arch. So these are the things. Now what really happens is, here at bulboventricular junction, this part goes rightward. So this is my right, this goes to the right, okay, and then this atrium and superior vena cava will go posterior to the ventricles like this. If this is the ventricle is here, you can see, I guess. So this is the ventricle, this goes posterior to the ventricles like this, and this is what the heart which we form. So there are ventricles downwards, and there is an atrium, so this undergoes posteriorly. So that is the reason anteriorly we have ventricles, and atria is a little posterior, right? And there is posteriorly, it goes to the posteriorly, right? So this is what happens. Let me draw the diagram so that you will understand what is really happening. So this one here, it folds and it goes posteriorly. So let me draw aortic arch, aortic sac, truncus arteriosus, bulbus cordus, and then ventricles. This ventricle will fold like this to the right, and this is the atrium, and this is the sinus venosus. And later this goes up and it goes posteriorly. Just see it. Aortic arch, aortic sac, truncus arteriosus, bulbus cordus, ventricles, it has gone like this, and then atrium and sinus venosus. Atrium and sinus venosus. Did you see the way that heart has been formed? So this is the ventricle, this is the atrium. So let me label it, you will understand. Aortic arch, aortic sac, truncus arteriosus, bulbus cordus, ventricles, atrium, sinus venosus. So aortic arch, aortic sac, truncus arteriosus, bulbus cordus, this is ventricle, this is atrium, and this is sinus venosus. So this is what generally happens. So you have got the structure of heart. Now primitive atrium always communicates with primitive ventricle via atrioventricular canal, right? So from the atrioventricular canal, there is development of endocardial cushions. So let me draw that. So here I am just zooming this part, ventricle and atrium part, not the others, okay, because I don't want to make the things complicated. So if you see, this is the ventricle one, and this is the atrium. So in between atrium and ventricle there is formation of endocardial cushions. This is atrium, this is ventricle. Between atrium and ventricle there is formation of endocardial cushions, both dorsally and ventrally. Even here and even here, dorsally and ventrally means if you just rotate it like this, you will have like this, and you have two endocardial cushions like this. Okay, endocardial cushions formed. This is this cross section, both dorsally and ventrally. This is the dorsal one, this is the ventral one, and this leads to the, then these two cushions fuse, so in the later diagram if you see, there is fusion of these two cushions. Okay, so this leads to the division of atrioventricular canal into two inlets, which are atrioventricular inlets. Okay, so at this stage this is the same. On cross section you will see like this at this stage. At this stage if you do a section, then you see this thing. Okay, there is two atrioventricular inlets. So if you do cross section like this, and if you see, on cross section like this, there is a, this is atrium, this is ventricle. Oh, sorry. So there is this long thing, right? It is dividing it into two so that the blood flows like this. Okay, from above downwards. Basically the blood flows from above downwards, from the atrium to the ventricle. It is cross section. Atrium is above and ventricle is below. If you see to this, atrium is above and ventricle is below. So the blood is both flowing into the ventricles. So this is what developed. So this is endocardial cushion. So now development of atrial septum and then ventricular septum. How does this happen? Okay. So now, I'm really sorry. Okay. So now this is the atrium, this is the ventricle. So this is the endocardial cushion, right? So now what happens? Just a minute. Okay friends, from the I did not like these colors, truly speaking. But I don't have an option. I'll have to use them, right? Okay. So, this is the atrium. This is the ventricles. So, now I'm going to explain you how the atrial septum forms. So, now from the superior wall, here this is the superior wall, towards the cushion, a septum forms, which is called as septum primum. Okay, this is septum primum, which forms from superior wall to the endocardial cushions. I'm just writing it so that it becomes easier for you to understand. And then the second, this hole which is seen, this is called as ostium primum. So now what happens? This septum primum will go downwards. I'm just drawing a little smaller one because this should fit in this page, right? Okay. Now this is the endocardial cushion. This grows towards the endocardial cushion, but because the blood flow should be established, a small portion superiorly, it becomes dissolved, and this is called as ostium secundum. So now as septum primum grows downwards, and fuses with cushions, a small mid portion of it is reabsorbed or resorbed to form the so-called ostium secundum. Right, so this is ostium secundum. So now this is the next. Right, and now this is the endocardial tube. This is septum primum which is formed, and ostium secundum. Now there is one more septum which is formed superiorly downwards, which is right to the, this is my right, so that is patient's right. So right to the septum primum, which is called as septum secundum. Okay, so in embryonic life, in intrauterine life, the blood flows from right atrium to left atrium, bypassing the lungs. So this hole right now, this is called as foramen ovale. Right, so this is called as foramen ovale. So here there is flow of blood like this, right? Bypassing the lungs. So this is what happens. And when the after birth, what happens? So after birth, when the, just a minute, After birth, when the pressure of left atrium increases more than the right atrium, this results in the pressure increases here and the right atrium pressure decreases. So this leads to the pull opposition of this septums primum and secundum, resulting in closure of defect, that is closure of foramen ovale, which is not a defect, which is normal physiological thing, leading to the formation of fossa ovalis. Right? So here the blood generally flows from left to right. Why? Sorry, right to left. Why? Because the pressure of right atrium is more than that of left atrium. After birth, once the baby cries, there is reversal of these pressures. So the pressure of left atrium increases when compared to right atrium. So blood cannot flow from right atrium to left atrium. So there is opposition of this septum primum and secundum, resulting in closure of foramen ovale, leads to the formation of so-called fossa ovalis. Okay, this is what happens in the atrial septum. Now coming to the formation of ventricular septum. So how is ventricular septum formed? So for the formation of interventricular septum, this is the heart. So this is the part. Basically this is the cross section of the heart, right? So this is the endocardial cushions. This is septum primum, which is already formed. This is septum secundum. Now let me take two more colors. I'll now take everything of pinkish. Okay, right. So now from the endocardial cushion, first from the interventricular septum, it grows up from this posterior wall of the heart. From here, from the inferior wall of the heart, a septum grows up, right? So this forms the lower part of the interventricular septum, and from the endocardial cushions it grows down. Okay, the endocardial cushions grows down towards it, and this leads to the formation of upper part of the interventricular septum. So the endocardial cushions, one septum develops from endocardial cushions. Okay, the lower part of the septum, it develops from the inferior heart wall or ventricular wall. From the ventricular wall itself, the lower part of the septum develops. These both, how are they united? Let me explain you that thing. So this is the heart, and now this is the endocardial cushion, right? So this is the septum secundum. Where is septum primum? Septum primum, and then this is the upper part of the ventricular wall, which is formed from the endocardial cushion, and this is the lower part of the ventricular wall, which is formed from the ventricular wall. Okay, the middle. This middle is from the bulboventricular ridges. If you see above the ventricles, cranially above the ventricles, there are bulbous cordus. If you remember, there will be bulbous cordus here. If you see three-dimensionally this picture, this is bulbous cordus, this is the ventricle which is here. From here it goes to atrium, and there above the atrium there is sinus venosus, right? Because it has been twisted like this, if you remember the first part of this lecture. So from the bulbous cordus, this bulbous cordus becomes remnant. Okay, ridges develop downwards, because from the bulbous cordus the ridges develop downwards and leading to the formation of middle portion of interventricular septum. It is like this part develops like this, the lower part develops like this, but the middle part develops from above downwards. Got it? So from the bulbous cordus, ridges develop, right? So these ridges form the middle part of interventricular septum. Okay, this leads to the development of right ventricle and left ventricle separately. Separation of two ventricles. Right? So from bulbous cordus and from truncus arteriosus, the bulbous ridges develop. These bulbous ridges will septate the truncus cordus also, and also the ventricles. Truncus cordus upwards and ventricles downwards. So these ridges also septate truncus cordus also. Sorry, truncus arteriosus also. Right? So now, so this is the development of the septa of the ventricles. Just a So now this is how the ventricles and atria develop. Then the upper parts. So we have right now completed the development of, let me show you the first, this one. We have now learned how the ventricles and the atrium develops. And bulbous ridges from superior come downwards and they divide the ventricle. Right? Now what happens? This is what is important. So right now, this part leads to the development of aorta and pulmonary arteries. This part should result in the development of inferior and superior vena cava. Right? So now, if you see, this is the bulbous cordus. So this bulbous cordus, it divides into a subaortic portion and subpulmonary portion. So this bulbous cordus orients itself like this. If you see, this is the bulbous cordus. This forms two major bulbs, which are subaortic portion is one, subpulmonary portion is other. I'll just draw the diagram later at the end, but let me explain you in this diagram so that you'll understand. This is the bulbous cordis. So this bulbous cordis divides into two portions. One is subaortic, that is below the aorta, and the other is subpulmonary, that is below the pulmonary artery, right? It forms into two portions. Now that this truncus arteriosus, it rotates. There is a spiral division which is there in the truncus arteriosus, and it rotates and aligns. So if you see the normal anatomy, there is aorta flowing like this. Above the aorta there will be pulmonary trunk which is passing, right? So because of this rotation and oblique division of truncus arteriosus, the aorta and the pulmonary arteries were separated, right? I'll draw the diagram, just 1 minute, so that you'll understand how things happen. And then this is truncus arteriosus, and then aortic sac develops and aortic arches are developed. Okay, so let me draw this diagram so that you'll understand. So if you see, this is the ventricle, right, and this is the atrium, right? This part is completely atrium, and this is the sinus venosus, right? Now this bulbous cordis, it's divides into two. Okay, and this is the atrium as it is. Even behind it there will be atrium. This is not the only atrium, it is even present behind it, right? So now bulbous cordis divides into two, which is two parts, which is subaortic and subpulmonary. Okay, let me draw one more diagram in the next page. So now let me redraw this. This is truncus arteriosus. Bulbous cordis divided into two parts, subaortic and subpulmonary, and then this is the ventricle and this is the atrium. Atrium has gone completely posteriorly, right? Okay. Now, and this is the second part of veins. Now the question is, this has been divided like this, subaortic and subpulmonary. Now what happens is, there is development of spiral ridge in the truncus arteriosus. So in the truncus arteriosus, there is development of spiral septum. Okay, there is development of spiral septum. This spiral septum will align. So if you see, this spiral septum develops, or spiral division occurs, and then it rotates and aligns. Okay, first spiral division occurs, then after a spiral division occurs, then this part will rotate, the whole part will rotate. Okay, now there is spiral division and there is rotation of whole part in such a way that what did I think this is? Aortic. This is in the left atrium, and now this should be in the right ventricle, sorry, the pulmonary tract should be in the right ventricle, and this aligns like this. And further, this is aortic sac and aortic trunk. So thus this forms the aorta. And now the second one, this forms the pulmonary trunk. Right? So this is what occurs. So there is spiral division. This spiral division, then there is the bulbus cordis and truncus arteriosus rotate, and they form in such a way that from the right ventricle there is pulmonary artery arises, and from the left ventricle the aorta arises. Right? So this is the formation of arterial system. There is still this is the atrium, and through the atrium there is still this sinus venous tract which is still not formed completely. So now what happens? So I think you have understood. Because of division of bulbus cordis occurs first into two parts. One is subaortic and the other is subpulmonary. And the truncus arteriosus, a spiral division develops first, and this spiral division rotates in such a way that when this rotates, the aorta should come from the left ventricle and the pulmonary vein should come to the right from the right ventricle. In that way the rotation occurs, and thus the arterial system is formed. Now coming to the venous system. So now arterial system is formed. So let me complete drawing the arteries. So this is one arterial system, this is the other one. Okay, so now what happens? So venous systems are bilateral and symmetric. So there is sinus venosus. So this is the atrium. So in the atrium is connected to sinus venosus, which is bilateral. It has two horns. So the sinus venosus has two horns. This is the right horn. So, where is my pen? Yeah, this is sinus venosus, has two horns, which is right and the left. This is right and this is the left horn. The left sided portions all regress except left coronary sinus. Except left coronary sinus, the whole left part regresses. Whereas the right horn, it forms into inferior vena cava and superior vena cava. Okay. Then what about the pulmonary system? The pulmonary venous system, it does not develop from the heart. It develops from the lungs, has buds. Develop as buds from developing lungs and fuse together at point where the systemic system regresses. Okay, so what generally happens? Let me draw a small diagram. So this is the ventricle, this is the atrium, so this is the aorta which has already been formed, this is the pulmonary artery. So now what happens? So this right system forms as two things, superior and inferior vena cava. This is the right one. So this is what forms as superior and inferior vena cava. The left horn, it has already been regressed and there is a small bulb. To this bulb, the pulmonary veins which are developing, they fuse. Okay. So these are the, sorry, I'm losing my pens in this whole pens. Pulmonary veins. And this is the superior vena cava and inferior vena cava from right horn. So this is what the complete development of heart. I'm feeling really happy for learning and looking out how this heart has been developing. You know, it's really a wonder to look at. See, the first primitive heart which is there, how is it? It has just 7 openings. 1, 2, 3, 4, 5, 6, 7. Now if you see, it has been first. It has first rotated itself, realigned like this. And after realigning, there is formation of, atrial septum, first endocardial cushions. And then formation of atrial septum. Okay, foramen ovale. And then formation of ventricular septum. And even still at this position the heart is primitive except the septums. And then the division of bulbus cordis. And then the division of truncus arteriosus. And now the best part, the rotation of this in such a way that aorta and pulmonary arteries are present. And then finally formation of the veins. See, this is the heart which we have, we all have, and it is pumping endless, it is pumping blood into our body endlessly till our death. So I hope after knowing about this embryology, I feel that God is great for this creation. Just see how the 7 small pouches, they were developed into the now adult heart. It is a wonder. So guys, this is about the development of the heart. In my next lecture, I will explain you about all the septal defects. I think each will be in one class. I don't know. It depends. But I'll explain you all the congenital heart defects in my next class. I know this video is really a little slow. Yeah, it is. Because drawing diagrams and everything, and even remembering stuff, referring stuff, all that made this lecture a little slow. But I'll make a review for it so that it becomes a little faster. So guys, thank you very much for listening to my lecture. If you have any doubts, you can comment it in the comment section. Thank you.